0.0001, and we have 0.1, one decimal point. We move it from here to here. Now that becomes 100. Do you agree on that? So that means we are allowed a change of 100 ohms. Now, that change says what? Do I add it back to have a 110? Do I subtract it and have 90? Or 900 rather? What do I do? I go back and it says, hey, my tolerance says plus and minus 10%. So the first thing I would do is take my 1,000 ohms, what it should be, and I add 100 to it, and it becomes 1,100 100 ohms. That's my upper limit. That's my plus side. If I take my 100 ohms that can be that it's allowed to change by and subtract it from 1,000, I now have 900 ohms. That's my lower limit. So now when I measure this thing, guess what? If it measures anywhere between 900 ohms up to 1,100 ohms, 1,100 ohms, it's acceptable. And all my projects are doing that. When you measure it, the last column is always going to ask you, is it in or out of tolerance? And what does that mean to you? If it's in, it's usable. If it's out, I cannot use it. I have to replace it. Make sense? So I measure the resistor, and it measures 987 ohms. Can I use it? Yeah, because it falls between 900 and 1,100, doesn't it? What if it measured 1,075 ohms? I can use it, right? What if it measured 901 ohm? Is it a between? What if I measured 900 ohms? I could use it. I would be a little doubtful about it because it's really on the very, very edge of being rejected or not usable. But kind of get the gist of this, the idea. So everything we're going to do, I'm going to have you doing approximately 10 resistors. Notice 300 ohms, 820 ohms, 1.2K, 4.7K, 8.2, all the way up to 1 megohm. What you have to do is this. Find the lower limit or the lower end that it's allowed, that is acceptable for it, and then the upper end. Once you have those down, you're going to go into the wow, there's a lot of stuff here. You're going to go into the cabinets, and you're going to find those resistors, and you're actually going to measure them. Now, look at page 2. Some of you, by the way, have 2-page ones when it was copied. Unfortunately, they copied the same page twice, and that's not a problem. Page 2 says, what is the lower limit and the upper limit for 330 ohms? Well, it's already done on page 1, so why should I do it again? What am I going to do? I'm going to transfer it to that page, right? I'm going to measure it. Then it's going to ask you, is that in or out of tolerance? Is it acceptable or not acceptable? And you're going to say in, yes, because it is, or no. And what we're going to do, if it's not in, we call it out, we're going to go get another one. And, all right? This is good because on your project, the next step you're about to do is exactly what this is. Only you're going to take your project parts and actually verify that they are acceptable. Strangely enough, everybody assumes that when you buy the kits and all that stuff that all these have already been pre-tested and already, no. The kit makers, the companies that make this stuff up and package them together, they buy them by mass quantity like we do. They take them out, they don't pre-test them, they throw them in a bag. And you get them, you assume that they work, and you put them in, they don't, and it doesn't work well. It works, sometimes it doesn't work, sometimes it doesn't work at all. But I put everything right, they're all the correct parts in there, yet it doesn't work. Nothing's installed wrong. Why doesn't it work? Well, some of those parts may not be acceptable. And we've rejected some in the past that were way, way out. I've had resistor color codes, by the way, that were correct, but they were painted to the wrong resistor. You know, it was brown, black, red. Should have been 1,000. I measured 100,000. Wow, that thing is bad. Well, I had a batch of those, so that told me right off the bat what? I bought the right parts. They sent me the right parts out of their package, but it really was the wrong part when it was put together. It was put together for 100,000, and they painted 1,000 on there. So these are the things that you never expect to happen, and boy, they happen. So now, as far as I know, I have nothing else to say. You have any questions, ask me? No. Would you do me a favor? And I don't mind, by the way, if you help one another out on this one, because It takes a little bit of practice. A calculator, if you want to use it, it's fine. If you want to use your mind in a longhand method, I don't mind that. But I have calculators in that blue box back there. You're welcome to use, providing you put them back. And I'll repeat one more time. I would prefer they stay in the shop. Some people come over, last week came over and borrowed them. I didn't mind. But a lot of times what happens is that they stay in the other room and never make it back here. And I short about 9 or 10 calculators last summer. I always tally these up because they don't belong to the school owns them. And if some of these go bad, I'll replace them. But if they're missing because somebody used them and didn't bring them back, then that's really not a good thing. Because then once I lose them, I don't have anything to give you to use. And that means you have to rely on your brain or your fingers and toes. And that's not really good. Right? You've already done that through the first, second grade of your education. Any questions? You got it done already. You're fantastic. Excuse me?
Scrap paper.
Scrap paper? By the way, this will be probably on your test also Friday. Now, naturally, I won't overdo it because you've only done this once, but I'd like to know that you know how to do it and what are the steps to do it with, all right? Does anybody require any assistance? I gave you a practice on one, by the way. The first question you answered is a practice one.
So,
okay?
I have a question.
No, let's do the practice one before you do the actual.
Oh.
What does it say to do?
It says below find the high limit and low limit for 100.
Okay, we know it's 100, right? What is the tolerance of that 100? 5%, 10%, 2%, 1%? 10%. That means it can change by 10%, plus and minus 10%, correct? So what would you do? What's the first thing you're going to do? What was the first thing I would do? I know it's 100 ohms. I know it's 10%.
330.
How do I know? No, we're doing the practice one.
Oh, yeah.
How do I know what the amount of change is? That's the first thing you want to do is find how much that resistor can change by.
10%.
10% of 100, right? Or, remember I said in your chart, we've already done that and converted it to decimal? So if I take 100 and multiply by, Mr. Gauthier, what is it? 0.10 or 0.1. You don't have to use a zero.
Multiply by 10%.
Oh, you can use a percent key. What if you multiply 100 times 0.1?
0.1.
What is that? 10. That means it's allowed to change by 10 ohms. Now, what are you going to do with that? Well, I have to find the lower limit, and then I have to, from there, find the upper limit. How do I do that? Well, what's my original number? 100. If I want to find the lower limit, what do I do? Subtract how much? 10 from it, which leaves me with?
90.
That's my lower limit. Now, how about my upper limit?
110.
110. See? And that's the same process for the rest of these. And you,
Where's the percent?
330, right?
yeah.
And then
What's the percentage of change for that 330? Times?
330 times. Where's the percent?
33.
33. Now, look at, you know what I should have done on that? I should have added an extra line. See the middle here? See the middle here?
Yep.
Put your amount of change here, and then work from there to find the lower and upper limits. All right?
Where's the percent? I can't find it on these.
Percent?
Yeah, it's not on there.
Yeah, you have to go in the second function. Second function equals, that's percent.
So, it's still giving me
100 times,
Oh, I already did that one.
Okay.
330 times.
second function,
10.
what's the decimal point? Yeah, let me see. I don't have my glasses on. Let's see. 330 times, times 10 second function percent.
Yeah, see it.
What's wrong with this calculator? 10 second function percent equals,
80.01, right?
yeah, it should be 0.1 for 10%, but you're trying to use percent key here. Something wrong with this calculator.
Are those working?
Yeah, but I don't know number C.
Yeah, I'm gonna go grab one of the bigger ones.
I mean, this just has a percent.
Yeah, see, it's not there's something wrong with this function key. The second function is not working well.
Yeah. I don't get like C. Do I have to convert it?
Yes, you do. Now, you see a K in there? What are you going to do? Convert it to whole values, right?
Yeah.
And then take the percentage. You'll find it much easier.
Is 3, right?
That's right.
High, upper 3. Right?
3 places, right? Is it smaller or larger than 1?
Large.
So you're going to move it, make the number larger, aren't you?
So I'm just going to move it, so
What-
it's going to be
The high limit is 33.
1.2, right?
Or 1,200.
1200.
Yeah. That's 1,200 ohms and 1.2 K are one and the same.
Oh, wait.
And by the way, you can work on the workbench. Mr. Ian over there took it upon himself, and he's actually right. That's a workbench evolution, so you're going to go there anyway if you want to. But you can do part here and the other part there.
Couldn't you just move the decimal place over once while I'm doing
Yeah, gee, you're brilliant. Amazing, isn't it?
Yeah.
See, you're starting to see that. It's a lot. You just hit on a really good thing. 10% of any number, you're moving the decimal point by one place, right? Yeah. Now, if you want, put the change here, and then you can, from there, either add it and subtract it to get your answers here. All right? Sometimes it helps to do it that way. Now it works. Yeah. See this? May I show you now? I don't know what I did wrong, but now it's coming out right. I don't have my glasses on again, darn it. Okay, look. Punch in 330 ohms.
Oh, can I do one that I'm on?
Yeah, sure.
I'm on this one.
Which is
1.2 K.
or
On 1200.
1200
Also, I'll put 1200.
times, is it 10%?
Yeah. No,
Okay.
5.
Okay, times 5. Second function. Now this, see, remember I said percentage, if you change decimal to percent becomes, 5% becomes 0.05?
Yeah.
Now hit the equal sign again. That's what we didn't do. 1200, now watch, times 5, second function, percent, that's how much you can change, that's the percentage converted over, equals 60.
Yeah, that's I got on this.
All right? So
So I gotta subtract 60.
now do me a favor. May I? That says you can change by 60. Put that 60 right here. So you know, sometimes you forget and you have to do it over again. Put the number that can change by in here, and then you can just add it and subtract to get your difference.
Okay.
Does anybody have any difficulty with this? Yes, must be doing well. So when you get these out and measure them, you should find that they fall pretty close to that tolerance range. And you rarely ever see exact measurements. The color code is fine, but again, they're made in mass quantities. You're going to find that they never read to the color code hardly.
Can you please shut that noise off?
What noise?
On my calculator?
Can you do me a favor?
Yep.
Take the tone off. Thank you. And you can do it after he's done. He just gets a little nervous when that's on there. Once you get this complete, go right and get those resistors out, because we're going to go right to the project after this one, and I'll feel comfortable giving the next section out. Excuse me?
Excuse me?
All right.
All right.
So you just put all the changes down, right?
Yeah.
So let's take the first one. It can change by 33, right?
So, yeah.
So if I want to find the upper limit, meaning how much can it go up to when I measure it,
I was just,
I take my 330, and what do I do to it? It's plus and minus, right? If I add 33 to it, it becomes what? So here's what you're going to do. You take your 330 plus 33, right?
Yeah.
And that's how high it can go, right there. That's your upper limit. Now, what are you going to do? You're going to go back to your original number, 330, and you're going to subtract it, because it's plus and minus, right? So you're going to put minus 33, and that's your lower limit. So that when you measure that value, it should be anywhere between here and here.
Yeah.
If it is, it's in tolerance. If it isn't, it's out, and we have to replace it.
Yeah, but like, what about like these?
Well, right now, pick one. Pick one.
Okay. What? Like this one.
Okay. 1.2K or 1,200 ohms. It can change by 60, right?
Yep.
Here's what we're going to do. 1,200, right?
Yep.
We're going to add 60 to it, and that's our
Answer?
upper limit, 1,260.
Oh, all right.
May I do something?
Sure.
Is that a 5%?
Yeah.
Yep, I just was double checking, all right? So I go back to my 1,200, and I subtract 60 from it, because that's my low end, right? So minus, that's as low as it can go. So, and again, when you measure it, if it measures anywhere between these 2 points, it's acceptable, and you're going to use it,
Okay.
all right? And that's the same for all of them,
All right.
all right?
Okay, thank you.
Some of you feel brave and want to convert your whole numbers to use prefix values. I have no problems with that either. Why? Because when you measure it with your meter, it may read out in a prefix value. So again, it's nice to associate the two as being the same. See how easy this stuff is?
Oh my God.
You're doing,
I'm doing the wrong one.
yeah, I think you did. Boy, you better learn to be neater. When I have to use some sort of decoding system to find out what you've written down, that's the high end, right? Did you add that? Very good. This isn't so bad.
No, it's not.
Once you start getting the hang of it, it goes really quick. You can almost do it in your head half the times. Now, you're all done, right? So you're going to go next door, over there. You're going to get your meter out. You're going to get these values. You're going to measure them. And you're going to tell me in or out, within or without, or outside of tolerance, I should say. You go wherever your bench is, that's where you work from, okay?
So when you do this part right here.
Yeah, well, you're gonna finish this
Yeah, I
page,
know.
right? And then when you go here, you're gonna transfer this to these two columns, and you're gonna measure and verify, and that's it.
On this paper, just getting those resistors and filling that
Yeah,
out.
that's it. That's already been filled out for you. You just have to bring it from the first page to the, all right? And again, please remember when you put the resistors back, they go back in the right slot, so we don't have this mixture in there. Once you have this down, the measurements go real quick, so it shouldn't take you more than a couple of minutes to do these.
It's not just
I want to find the person who keeps putting these resistors down on here instead of putting them away. See, this little box here is for people who I find to do something wrong. This becomes a sorting box to help me put these back in.
That's very good.
You need a 10K?
I need to.
No. Is there a 10,000 drawer in there?
You getting one for somebody else?
Is this 10K?
No, don't do that.
Okay.
What's the matter?
He has to find it. He has to find it on his own.
Who told you? Are you kidding me? Is he paying you to do that?
Is that 820? Yeah, it is.
Oh, right. Be careful, because it could be different. Somebody may have put a resistor in the wrong slot. Don't rely on the numbers being correct.
I'm looking for just
You're gonna have to do it
820 ohms.
yourself.
820 ohms?
Right there.
Remember what I said, always verify the colors.
Yeah.
And by the way, if you do in fact measure a value that sort of says, boy, this is way out from what it should be, double check your resistor, make sure you have the right colors in there. Boy, this guy knows what he's doing. A lot of this stuff is repetitive, because I try to jam it into your brain so that you wake up at night screaming, I know what it is, I know what it is. After you're done with this, we're going to go into the project, and we'll do the next 2 steps real quick. And then we get into the soldering part. Again, this is a lot of work, but you know what? This all relates to what you do during all your projects.
That's a good idea.
What?
Write it down so you don't have to keep flipping the page.
Well, it makes you feel better.
Makes you feel better about yourself.
Yeah. Is anybody ready to measure yet? I'm getting curious. There's some on this side, you know.
Nope, I know that's why I came over.
that all the same?
Are there some? Well, they're backups for that.
Yeah, 18K is not over there.
There's none?
No. Did you find 18K?
Back here, still stretching.
We may be out.
Can you get? Can I have a blank piece of
Here,
paper?
give me an 18K, so we can.
24.
You need a blank piece of paper? Look on the student desk right up front. I brought some over.
There's 22. Where's 24?
20. Do you get any 24Ks in there?
Yeah.
Right here.
And 2 of them.
Let's make sure they are 24s, right? Does anybody else need a 24K? Wait, I'm running out. I have to go fill the box again.
Oh man, I should have put them in order like you did, because now I'm going to have to figure it out.
Yeah.
But, oh
See,
well.
George over here, he makes pin cushions out of my paper, but he's doing okay because they won't go out of the way.
Yeah, but you can just figure it out kind of easy.
Huh? Yeah, that's my way. The more you look at it, the more you work on it, the more easier it's going to be to remember.
Oh, that's not
We're
it.
down to the last one.
Yeah. No,
What do you
it's
need?
the last.
Right here.
Well, we need this one
Well,
anyways.
this is my last one.
You're done. Yeah. Make yourself some room here. Well, remember I said, when we get into wattage ratings, you're gonna. Yeah, that's an eighth of a watt.
Yep.
That's a very. Yep, it's very low power though. You can for measurement purposes, it's fine. when you take your first measurements, I'd just like to show me what, geez, you're copying his? You have your answers right on the front page.
I know, I don't feel like going back and forth.
Oh, I'm too lazy. Can you do it this way?
Yeah.
Or maybe, in fact, we can do it this way.
Like that.
There we go.
That'll work.
We can just restaple it.
Yeah.
When you take any measurements, try to clip those on real tight because they need a good connection to measure. Now that's a perfect one. Now you wrote down 330, correct?
Yes.
And it reads .330 though. No?
Yes.
Why is it reading .330?
Because it has a K.
A K. I'm glad. See, that's what I want to see. You see that, you automatically convert it over to value. And anything more than 1,000, you know, remember the rule of thumb says you can use kilo and all that, which I don't mind. You can do that as long as you understand what you're doing.
Do you have so different answers than me?
You might write it
There's another one.
You might get it wrong.
So you know what you're doing. Now, when you look at that, when you're done, you're going to compare these two, right? Very good. See, this is what makes a technician and not just a assembler. They rely on whatever somebody gives them. A technician knows what they're doing, and they know that they can verify what they're doing. So when you do some repairs,
2,700 and a 1,200.
see, that happens a lot. That's what we have to be aware of.
Do these look right to you?
Well, did you do these here?
Yeah.
Why not? Why shouldn't it be right?
I don't know, because he has different numbers.
No, these are pretty close to the same as yours.
7,300. I had 7,380.
Well, how much change was that? 8,200?
82.
No, that can't be right, because you got 8,200, and you say it can change by 7,000. That's not correct. Now, take your calculator. 8,200, right?
800.
8,200. 8,200. Now, what's the change? How much can it change by? 10%?
Yeah,
No.
so it's 820, right?
Yeah. So that means it can change by, actually, yeah, 820.
So,
So you put 820, and if I add 820 to that, it becomes what? Take 8,200 and add 820 to it. That's your upper end. That's 9,200 and...
that's what I got there.
Oh, then... Oh, that's right. Now, what are we doing wrong here, then? These numbers are correct.
Yeah, but this one isn't, you know what I'm saying?
Okay, 8,200 minus 820.
Minus 820.
That's the lower end, right? 7,380.
Yeah, so mine is right.
What do you... You doubt yourself?
No, he must have got it wrong.
Maybe he got it wrong.
Yeah.
This here, by the way, this is wrong.
What do you mean it's wrong?
Because I see a number like 18,000. It cannot change by 16,000. That's impossible. That's got to be the lower end. Oh, that is the lower end.
Yeah, what do you... I don't
I'm
know what
asleep. I'm sorry. I didn't wake up yet. I was thinking that was the change.
No.
That's fine. You're doing everything right.
All right.
You're doing everything correct. Did you take any measurements yet? Are they in or out of tolerance? That's the next column. That's what we want you to verify, all right?
So even if we get a bad measurement, we write it down?
Yes. If you tell me if you do, by the way, I'd be curious.
I still don't think these are right. Yeah.
Well, that's what you want to double check. Make sure the colors are correct before you measure them. You may have taken it out of the right drawer, but the resistor was put back from someone else in the wrong drawer.
These look like 100, 1,000 or something.
This is, what color is that?
Brown, black, red, gold.
Okay, brown, black, red is what? 1 0 with 3 zeros, 2 zeros, right?
Yeah.
That's 1,000.
Yeah.
You don't have a 1,000 there, correct?
Yeah.
Same with this one. Somebody put these in the wrong drawer. You're looking for 1,200, 1,200, correct? 1,000. 1,000. 680, 820, this is 1,000. Where's the 1,200? Here, try this one out. Take a look at that color. Yep, you're done? Yeah, I can put them back. And please answer the questions at the end, because it's going to refer to what you just did and see if you understood what the exercise was all about. 2,700? I gave you that one? No. Would I have done that? That's red, violet, red. You're absolutely right. Gee, I didn't check either. Do you have one that says 2,700 in here, drawer?
24,000.
2,700?
I can't find it in the No, it's 2,400.
No, but is there a drawer that says 27 on here?
No, it goes from 22 to 23.
No, it must be in the other one then. What are you looking for? A 1,200?
Yeah, 1,247.
1.2K?
Is right here.
See, now I just took them out. Now, if somebody tells me, are these brown, black, brown, red? No, somebody threw a whole bunch in the wrong drawer.
That's wrong.
100,000.
It was 330.
Make sure you get the right color codes. It's important.
What was it? They looking for 1.
Listen, you students, if you don't find it in those drawers, look back here. There's 2.4K, there's 18K, and there's 24K. So look in those drawers back here also.
I got him. George gave him.
Oh. George, you wanted to ask me something. I heard you say something.
Yeah, I said Mr. Gouvet, Mr. Gouvet.
Okay.
I was trying to tell you that.
Make sure you put those in
I know.
the
I'm gonna
first
put it
column,
down
because
from
now
here.
you're going to compare those to that and tell me if they're in or out, all right? Are they in or out? Whoa, I don't see some. I see some I don't like. Yeah, that's better.
I was gonna put
Ah,
see how I knew right away.
okay. Well, yeah, when I look at 18,000, I see 18. That doesn't make sense to me.
Okay.
Remember what I said, when you measure these, don't just look at the numbers. There's something beside it that tells you how big or large, small that number is. Oh, we're almost done. This is wonderful. So now you're the experts. Anything we do from now on, you should be able to understand that you need to know this stuff.
There's no 18.
Having problems finding some parts? Are these extras?
Yeah, they were there, I guess.
Nah, I'll take them.
That's the one he was looking for.
1.2K?
1,200.
Well,
This
see, I got a
is
feeling.
2.7K. 3 zeros. 22,000. There's 22.
That should be down here somewhere. I got to remark these drawers. They're starting to fade. Now this is the 1.2s.
18,000.
Yeah, see?
There's no.
Somebody put a 2.7 back. 2.7. 2.7. Boy, there's a whole bunch in here. Somebody dumped something in the wrong drawer.
0. 1 minute.
Yep. Now, you've taken the measurement, right? Now you're going to compare them to your tolerance. The ones you just calculated. Do they fall between the low limit and the high limit? If they do, that means they're in tolerance, meaning they're within they're acceptable. And if they're not, if they fall below that number or above that number, then they're not acceptable and you have to replace it. Yep. Can you do me a favor while you're doing that? Well, you're complete. I want to remove the 2.7 Ks from here. It should be brown, red, red, and I'm seeing red, violet, red. I've taken a whole bunch out already. See if there's any left in there.
Now or after?
One of mine are out.
Yeah, now, if you can. Oh, you can answer these questions first, that's
One of
fine.
mine are out.
It
Oh,
is?
no, it's not. No, that's in.
Yeah.
60. Yeah, they're all in. Is that
Okay,
good?
now you can answer, now you can answer these questions. Now, what function was used on the digital multimeter? Now, I said it, that's correct. If you're not sure, you look at your meter, all right? Ohm's function.
No, isn't K ohms?
No, the ohms function means, what are you trying to measure, ohms,
Oh,
volts,
just
or
like
amps?
In general.
Yeah. Now, what happens on the second question is I'm using my meter and I try to measure resistor and I get a 1 with a decimal point on it.
It won't. I can't read it. It's too
It's
low.
too low. You have to go to the next higher
I
range.
can't find this one.
1200, I got the draw right here. We have a mixture in here. We're trying to straighten that mess out. Hi there.
Hi, if you whenever you get a chance. I was just, I was down, I saw Tony Coco, and I have something that, it has something to clean terminals, he says. Do you have anything, any spray at all? Is there any kind of a spray that I can
Cleans the
purchase?
terminal.
Yeah, the socket goes into the term, and my lawnmower is not working when I press the button for the blade to go on.
Yeah.
He told me to clean the place where the hook's on, you know what I'm saying, so electrical. And he says, well, sometimes it gets dirty, they might have a spray.
I have a spray cleaner,
Cleaner,
but
that's
it may or may not work. I'm not sure.
So this one would be 47K? 4,700 ohms?
4700 is not 47K.
Oh, it's this one.
This lubricates. I don't know if you want. That's going to put an oil film on it when it's done.
Clean it, he says.
Yeah. Let me take a look. Oh, not too bad.
The old veterans, Peter and all those guys. And all.
Peter comes in every year.
he comes
He
in.
drops in to say hello. Yeah. This year, I only saw him once this year, so he must have been busy doing other things.
Yeah.
Okay. Greaseless lubricant, we don't want that. This stuff here will work, I believe. Lubricates, frees rusted parts, stops corrosion, displaces moisture, and improves electrical
Yes,
properties.
Okay.
So,
I can use it and bring it back to you.
yeah, and I'm missing the nozzle tip. That's the only problem. There's a little tip that goes in it. I'll borrow this one.
I really appreciate it. Two of my loins, then the thing dies out on me halfway through.
I know the feeling.
You know. So,
Let's see if that works. Yeah, that'll work. Oh, look at that. Awful.
maybe I can cut it and
Yeah.
use the rest of it. That's fine. I'll cut it. Just snap it off. Use half of it.
All right, what I'll do is, yeah, just snip that piece off.
Okay.
That
yeah.
should snap right on there
Okay.
somehow. Whoops.
Give me that. I'll put it in my pocket. Thank you
Okay.
very much. Okay, I'll try it. I appreciate it. Thank you.
Yep. Found a lot, did you?
I just got
Okay. What is one of the most important safety considerations? Okay, I have not explained that to you. But when we get into real life circuits, when you measure resistance, you always have to make sure the power to the unit that you're working on is off. Because the battery supplies power, and if it's already got power in it, they're going to conflict. And what's going to happen, something's got to give, and it'll probably in the meter, it'll be destroyed. So you never measure resistance with the power on. That's the answer. Okay? Garrett?
Yeah.
The last question, it says, what's the most important safety feature of a multimeter? And I'll tell the rest. I didn't explain that to you.
There's a few.
When you're working in a live circuit, meaning you have something you're trying to take a measurement on, we always make sure the live circuit is turned off. There is no power when you measure resistance, for resistance only, because it supplies power, voltage, and the meter supplies power, voltage, and then you'll have this conflict when you're trying to take a measurement. Usually what happens, the meter loses and it destroys the meter or blows the fuse.
So pretty much make sure the what?
The power to the unit that you're testing is off, always off. That's a good safety. Yep, just turn that in. Done? Wonderful. Mr. Oakes, you're done?
What does this mean, in, out?
That means when you take the measurements, you're going to compare them to your low limit and your upper limit, your high limit. If they fall in between those two numbers,
Oh, you put it in?
it's in. If it doesn't, it's out. Now, we're going to go into the project right after this. As soon as you put your stuff away, we're going into the project, and we'll get this underway. By tomorrow, no later than tomorrow, you should be putting that thing together. Hopefully today.
Wait, how many people are done already?
Well, you're one of the last who isn't done. But that's okay. We don't rush you. The idea is learning here. This is important stuff. The project stuff is fun to do, but I would like the learning stuff to come first because it applies to the project. Are these all the 2.7s? Holy mackerel, a lot of them. It could have been me that did this, and I hope nobody hears that.
16.
2.7K. Something wrong? Okay, now, I see when you see a 1 with a decimal point, that means your range setting is too low. You have to crank it up till it reads. Now it's reading 67.2 what?
0.2 k ohms.
So what resistor are you trying to measure then?
This one.
Okay, so you're going to write that in right there, correct? Actually, that's a good thing you did in a way. Because see, when you see stuff like that, what is that telling you? It's telling you that it's trying to measure something,
It's too low.
but the setting is too low for the resistance. So what are you going to do? You can crank it up till you get a... Typically, you like to have whole numbers and not, decimal numbers. See, this is the easy part. When you get into a real life circuit and everything's soldered to the board, that's when you start having to get in there and trying to take some measurements.
Mr. G, how do I do this?
Okay, you're just taking a measurement, right?
Yeah.
It's, why are you way up there? Now, we know that it should be, look at this number. It's just something that will fit 330 comfortably, right? Well, we know 200 is too low. Look what it just told me. When you see a 1 with a decimal point, your setting is too low. So what are you going to do to cure that problem? You're going to move it up by 1. And guess what? It's still too low. What are we going to do now? We're going to move it up by 1 more. We're going to move it up again. Ah, it reads. What is it reading?
67.5.
What else is it? I'm on this scale here. What does that say beside that number?
Okay.
So my number has to be in K. And that's the wrong resistor you have then. That's the resistor you're measuring here.
Oh, that's right.
Be careful. I'm going to give you a big eraser. You know that? You have this tendency to scribble a lot of stuff out of here. And the problem with that is that when I try to read the answers, I'm looking through scribbles. So we're going to work on that a little bit. Okay. Understand?
Yeah.
Now, does that fall between 61.2K and 74.8K?
Yeah.
Now, you notice I said K and K?
Yeah.
That's the same as 61,200,
Yeah.
right? If I converted that to whole numbers, it would be 67,500. Do you
Yeah.
agree? So it falls in between. It's in, right? And that's really what you're doing for the rest. Just verifying that these things work correctly. You helping them out? Fantastic. We're going to get into the project, so make sure you have your project stuff ready because I'm going to start pumping out some stuff for you, all right? You got 2 steps to do today at least. Mr. Gauthier, you're going to lose your pants. I can see your underwear. It's kind of embarrassing. Not like talking to somebody's face, but I'm looking and talking to the other end. It was embarrassing.
Can I go get my toolbox?
Yes, you can. You can get your toolbox, you can get your stuff, and I guarantee you, if we do this right, you'll be working on that project today. Unless you do something wrong, then you'll be working on it tomorrow, or maybe never.
Are we taking everything that you
You're going to get your toolbox out? Yeah.
every sheet project?
Yeah, but you're going to leave it there. Leave it there. I'm going to hand you out some new stuff. Now, yeah, we're going to set that up for about 570 degrees today, all right, just for printed circuit board work. How are we doing there? Are we getting close to finishing?
I don't get this one.
You get your job all done?
Yes.
Make sure you turn it in, would you please?
Sure.
You don't get it. What don't you get?
So it's 82, right?
Yeah, but now look, before you do anything else,
Oh, never mind, I get it.
what are you measuring? You're on the 2M scale. You're in megohms, right?
Yeah.
You notice you can't read there, right? So that's 0.81 megohm. You agree? You agree with me?
Yeah.
What is that in thousands of ohms if I were to make it thousands of ohms? Remember I said everything's separated by 1,000? A million is 1,000 times greater than? So if I move it 3 places, it becomes
14.
1,000, right?
Yeah. Could be in, right?
And if I wrote it in base numbers, it would be 814,000. Now, you understand it to be 814,000. You agree on that?
Yep.
And that's what I'm looking for. You're almost done. You're done, you're done, you're done, you're done, and I only have 2 people left who are answering. Now, this question here says, assume that I'm making a measurement, all right? And let me do something. Can I borrow a resistor you've already measured right here? Here, put this on your meter and measure that.
No.
Oh, you had some here. I could use that one. Just doesn't matter. I want to show you something. I think I've already showed you that.
Yeah, the one
If you,
comes
one
up
would-
when it's
it means what is it telling you? That's what this is asking you right here.
Okay.
What is that explaining? What is that telling you when you see it?
Wait for the printed circuit board today?
I'm going to give you the next 2 assignments on that, and then you'll be on the board. Now, the next question says, what should you do to correct that problem
Move it up.
to the next higher ranges, right?
Oh, before I did.
Now, you are preparing your soldering irons before you use them, correct? Getting them ready for work?
Most important safety.
And you're wearing safety glasses when you handle all that stuff, so I don't get any solder in my eye, or I don't burn myself. Being very, very careful. We only have 1 set of eyes in here. If I cut wire, if I bend wire, if I use any tool, I must always have those glasses on my face, protecting my eyes. I'm looking at a soldering iron, I'm preparing a tip, and I have the glasses on top of my head. There we go. That's a bad feature when you do that. Even doing that, if there was any solder on a tip with that brush, you could have brushed it back in your face. These are the things that happen all the time when you least expect them. Okay, most important safety factor to consider when using an ohmmeter to measure resistance in an electronic circuit. You're going to build a circuit right now, okay? And you want to test the resistors in there. You want to make sure the power in the unit, the circuit itself, is off. Because if it's power in the unit and you're trying to measure the resistance, there is voltage on these leads when you place them on there. So the voltage from the meter compared to the voltage on the unit, they're conflicting one another. Usually the unit's too high, higher than this, and you just damage the meter. So the power to the circuit must always be off. Okay? Ready to go?
Safety glasses disappeared.
Your safety glasses disappeared. How can that happen? Nobody uses your toolbox. Didn't I just give you a new pair of safety glasses too?
Yeah.
Gee, I don't know. I have to make you buy a pair, I guess. Let's go look to see if we can find them. Maybe they were misplaced. Maybe you left them on a bench somewhere and was picked up. A lot of times I pick them up and put them in here, and I don't see them in here. Are those the type you had?
Oh, it says 4A.
Are those yours?
I don't think so. It looks like this. So.
Are you number 4?
Yes.
We'll take that one. If there's something wrong with them, I'll get you a new pair. Those are the ones that were in the toolbox, that type, that style?
Yeah.
I'll get you a new pair if you prefer. Would you rather have a new pair? You're going to put them over your glasses? Look at, make sure one thing. when you bend down, they don't fall off, all right? It's important that they stay on your head. Okay? Yes? No?
Yes.
Okay. If they give you any problem at all, I'll replace them. And if you really rather have a new pair, I'll replace them. How's that? I'm giving you that option. You want a new pair? Okay. All right, can I have you students at the student station, student benches, please? Desks, whatever the heck you call it now. Because I'm going to hand you out the next task for the project. You done? We need to get you at the desk if you're done.
I'm done too.
Okay. Make sure you turn everything in. From now on, by the way, when we start doing labs, I have to sign off on them before you turn them in. Is that understood?
Hey, do we have to do the bottom of this now?
Yeah, of course you do.
Now?
Of course you do.
We turn on soldering irons though?
You leave them on. It won't hurt to leave them on. Leave that on. First question, what is it? What's the question saying, asking you?
What function was used for the minimum?
Okay, function means am I measuring ohms, volts, or amps? That's the ohms function, right? Now assume that when you took a measurement, what happened? I was measuring a resistor, and this is what I measured. This is what I saw on my meter.
Yeah.
1 with a decimal point. What does that indicate to you?
That's not enough.
I'm on a wrong range. I'm on a too low a range, right?
Lower. All right.
Okay, and it says, what should I do to correct this problem?
Move it up.
Move it up to the next higher range, and all of a sudden it reads now, doesn't it? Now, what's the most important safety factor to consider when you're using this to measure devices in an electronic circuit? The power to the unit must always be off.
Okay.
Because if you're putting power from the unit, this is supplying power, they're going to conflict with one another, they're going to crash against one another, and usually the meter loses. Okay?
And that's it, right?
Yep. Okay, I want to get started on the project. Listen, make sure, and I will repeat one more time, normally what I do, when you do the experiments, are we listening, gentlemen? Do not turn them in even though they're done until I've signed off on them. Because what I normally do is double check what you've done, and I may ask you a question or two to see if you understood. All right? It's really important that. If I don't sign off on them, you turn them in, I will not give you credit for it. I'll give it back to you the next day, and I'll just say you got no credit for it at all. And you'll say, well, I did all the work, and I'll say, you probably did. But if I didn't check it, my assumption would be maybe you worked with another person, you copied all his information down. Did I learn from that? Not really. So if I check you off, it means I understood that you know what you're doing, and then we can proceed on to the next stuff. Is that agreed?
Yeah.
Okay. Now, we're on to section 6 or 5 of the project. 6. Now, this is a 1-second handout, but it's important because it tells you something about the procedure you're going to follow to assemble this project. All right? Make sure you're in the project section. Wow, did I run out? Yikes. Now, it's important that you listen because this is all read practically, okay? When you get the circuit board, which you have in your possession already, okay? If you look at the procedure, and by the way, I do this for one reason. If I explain this to every one of you, I'm going to run out of time. I'm going to run out of breath. I'm going to run out of everything I don't want to do. I like to explain it once. The procedure, are we listening? The procedure gives you all the information you require. We know it's a single-sided circuit board. We know that one side of the board is copper, has copper traces on it. We know that the holes are pre-drilled, so we don't have to add wire. We know that the component leads go through the holes on the opposite side, which is called the component side. We know that the side of the board where components are mounted is called component side. The other side is referred to the foil side. The copper runs make the need for connections, wire connections. You don't need those. They're already there for you. We know that copper is a good conductor. However, copper becomes contaminated with dirt, oil, and other foreign materials, and as well as something called oxide. And again, oxide is nothing but copper when it's exposed to the air, mixes with the air molecules and the copper molecules, and creates a film on top of the copper that we have to remove. I have you use alcohol just before you solder the board, even though you said, hey, it's brand new. Why should I have to do anything to it? It looks new. I can touch it with my finger. My finger has dirt on it maybe, it has oils on it, your hands have oils. As soon as you touch that copper, it's contaminated. We must clean the board before you solder them, okay? Now, how do we clean it? It gives you, it gives you a example of how to clean it. You can use a denatured alcohol, you can use a brush, you can use a pencil eraser. That's called an abrasive. We rub it till it becomes nice and copper looking. If you look at your boards now, they look like brass. It's a little dull finish. Even though they look clean, they look new. But if you were to clean it properly, they should look nice and shiny, coppery looking. And that's the difference. That means it's ready to be soldered on. And again, solder embeds itself into the copper. It doesn't sit on top and glue things together. It has to mix with the copper itself. Now, after cleaning the board, you're going to be asked 3 questions. Are the pads clean? Yes. Are there any defects on the board? Well, you've already checked all these, didn't you? So you can put yes on those, can't you? The component side. Are all the component symbols located on the component side? What does that mean? If I want to insert a resistor, R1, into the board, is it identified on the board? Right? I'm going to give you a project, by the way, right after this that has no markings on the board. And you're going to have to rely on your diagram to locate where they fit in on the board. That's the fun part of it. Right now, that's the easy part. Everything's identified. Just look, boom, 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 sorry, you're done. That's done. Number 6, no questions, obviously. Number 7, this is the fun part.
You didn't clean the pad.
You will before you do it, okay? Number 7 is what, wow. Hey, I just did this. Why am I doing this again? Because this is part of the real project. And if you hold off a minute on that, I'm going to give you number 8 right behind it. And number 9 right behind it. Wow, a lot of stuff, huh? Make sure they're numbered correctly because you're going to be checking this off on your project. Remember the front sheet? Make sure you have these and they're checked off because that's what I'll be looking for at the completion. Hold off doing 7 until I give you 8 and 9, all right? And after that, it's all assembly work. George? This is the schematic diagram. Now, we know what a schematic is, right? You know, it's very strange. I ask questions and answer my questions without even getting answers from you sometimes. What is a schematic? What's important about a schematic diagram?
Even if it doesn't have pictures on the printed side,
Yeah.
it'll tell you where all the parts
How does it identify the components?
with their symbols.
Symbols, okay? That's the important part. And by the way, one of the exercises I gave you a couple days back, it said, what is this symbol? It had a line going to another line with a dot on it. We know what a dot is? That's a true symbol, by the way.